So welcome guys to Computer Science TV. We're going to talk about a CPU stall. So what's a CPU stall? Well, this is the state that is reached by the processor when the CPU actually runs out of instructions to do while it's waiting for a cache line. So first, it's actually important to understand what a cache is. And of course, if we're talking about a cache, a CPU cache specifically, we mean a hardware cache that is used by the central processing unit of a computer to actually reduce the cost of data access from the main memory. So if this is the main memory, this is our cache, then this is the CPU. Then of course, normally instead of the processor going all the way to the main memory to actually access data from the main memory, then it's going to check if there's a copy of that particular data in the cache. So if that particular copy exists, then it's going to fetch that particular data in the cache instead of from the main memory. Of course, this results in reducing the cost of data access from the main memory, the cost in terms of time as well as the energy that is consumed. Okay, caches are normally have they are normally smaller, closer, and also faster than the main memory. They also of course are closer. So this then reduces the cost of data access in terms of both time and energy. So yes, as we've seen, of course, normally the caches are going to improve performance. They're going to actually they're faster than the main memory. Okay, however, even though they are much faster than the memory chips, of course, if as compared to the processors, actually they are very slow. Okay, so CPUs are actually much faster, and in fact modern processors are even becoming faster and faster as compared to a memory chip. Now, for example, imagine this is a CPU right here. All right, so we have our processor, then we have our CPU cache. All right, so of course the processor, if suppose for example it needs to read or write some data to the cache, then yes, it's going to go ahead and then now read and write. Now in that process whereby actually data is being actually written into the cache, okay, of course that is actually going to take some time. During that time, the processor is going to be waiting. So while the processor will be waiting for data to actually be written to or accessed from the CPU cache or read from the CPU cache, then of course the processor is going to be waiting for the CPU cache to actually finish reading or writing data. Okay, now the cache, as we've said, they are not as fast as the processor, even though they're faster than the main memory. As compared to the processor, they're still very slow. So the processor is going to be waiting, and that is what we actually call a CPU stall. That period whereby that state that is actually reached by the processor, when the processor, instead of performing work, is actually waiting for a cache line. Okay, so it's waiting for a cache line to actually return. So that is what we mean by the CPU stall. Now of course that particular time right there, okay, when the CPU is actually stalled, that process is going to displace of course potential computations, because the time that we're going to be spending while waiting for a cache line to return, we can perform, a processor can actually perform can actually execute hundreds of executions right then. Okay, so if we're talking about a CPU stall, that is what we mean, the time right there that the processor right is waiting for the read and write of data to actually occur in the CPU cache. So to counter CPU stall, engineers have actually been employing two main techniques to actually keep the CPU busy during this time. Now the first one is called the out of order execution. Then you also have the simultaneous multi-threading. So these are the techniques that have actually been employed in the latest CPUs to actually try to keep the CPUs busy during a CPU stall. If we're talking about the out of order execution, all we mean is that the processor is going to attempt to execute independent instructions after the instruction that of course is waiting for the cache actually misses the data. So this is a technique that is employed by the latest Intel designs as well as the Intel Pentium Pro. Then the second technique is simultaneous multi-threading. This is also known as hyper-threading. Okay, of course, with this particular technique right here, now we're going to have alternate threads that can then use the CPU core, while the first thread is actually waiting for the required resources to actually become available. So of course, this is a demonstration right here of hyper-threading. These are CPU. Okay, the green one right here, of course, is our CPU, is our processor. Then of course we have the thread A and thread B. Of course, a thread is just a line of execution. Then we have our CPU cache right here. So yes, of course, the first thread is going to try to access some data from the CPU cache, and then of course during that waiting time, of course, this is what we should actually call the CPU stall. So while the data is actually being read and written to the CPU cache. So of course, now what we're going to do with the hyper-threading, instead of the whole processor waiting for the cache line to actually return, then we're going to continue work, of course, inside the thread B. During this time, we can actually execute hundreds of instructions. Okay, during that time, that period, the waiting time where we're waiting for the cache line to actually return, the thread B is going to continue processing some work. So this is what we call the hyper-threading right here. So that's it for Computer Science TV, guys. Take care. I'll catch you in the next class.